Welcome to the Industrial IoT Spotlight, your number one spot for insight from industrial IoT thought leaders who are transforming businesses today. With your host, Eric Walenza.
Welcome back to the Industrial IoT Spotlight. I'm joined today by David Knight. David is the founder and CEO of Turbine, and Turbine's a very interesting company. They're building the first digital marketplace for IoT and sensor data about the physical world. And so they're focused today on transportation and smart cities, but this marketplace concept is obviously transferable to any industrial market where you have a lot of actors that are collecting information and where this information has value to some other third party, whether it's an internal third party, so it could be crossing internal data silos, or an external. David, before we really dive into the company, first, thanks for joining us. Really appreciate you taking the time today.
My pleasure.
Before we dive in, if you can just spend a couple minutes and give us some insight into your background. Where are you coming from, and how did you come upon this quite innovative idea?
So my background goes back to early days of being curious about technology when I was pretty young, and then I ended up specializing in applied physics in school. I ended up also working in things like the entertainment industry on the technology side, eventually focusing more and more on computing. I've been involved with, for example, helping to establish the commercial email industry. We had the first company that built big commercial email servers called ISOCOR, which we took public. And then I was also involved with a fun thing that turned out to be a lot of work called the X Prize, which informed a lot of what I'm doing now. And so in 2004, I met a gentleman named Dr. Peter Diamandis, and he had this crazy idea that only governments built spacecraft and sent people to space, and what if we created a private space industry? And so he raised $10 million and offered it to whomever could build their own spacecraft, take it to space, and if you did that successfully, you won $10 million. So I joined his group. It was a nonprofit group back in 2004 as their first vice president of business development. Nothing that I was paid a salary for. It was just a fantastic experience. And in fact, at the end of that year, we saw the world's first private spacecraft with a person in it called Spaceship One go to space, land right in front of us. And then that led to Sir Richard Branson creating Virgin Galactic Space Lines right there on the spot. Since then, I've been involved with a number of technology ventures leading up to recent times when I started to look at the abundance of data being generated by what's now called the IoT. And I kept seeing the layers of the stack forming, if you will. The first was device level. It was clear that an abundance of devices were being developed. Eventually, we'll probably have devices in us. They're certainly already around us. I seem to talk to one all the time called the Amazon Echo, and many other things, and all the way up to space itself, satellites and so on. So I figured that was covered. I also saw many organizations, including industry standards groups and companies, working on the communications part of that. So that's your wireline, wireless protocols. The next thing would be, well, how do you securitize that? I would say there's probably several hundred companies now working on IoT security. And then the next layer up was going to be the software itself. So those are IoT platforms, IoT analytics companies. And it seemed like there were a lot of those too. And now listeners here would certainly be aware of the fact that there are many IoT platforms, and some are specialized in different vertical industries like healthcare, retail, manufacturing, supply chain. But in essence, they're essentially almost like data brokers that take the data, collect it, and then make it available for any kind of use, like an analytics program. So where was the big opportunity? What was left? And we kept looking up the stack, and there was a big void above all of that. Where was the big exchange in the sky that would interconnect all of these things and facilitate transfer of the data in a curated way? So we started to realize that might be the root of a very big opportunity. In fact, so big that it would become a major tentpole company all by itself if we executed well and with a little bit of luck. So that led to the founding of Turbine about 2.5 years ago. I was introduced to a brilliant software architect who had worked at places like AT&T and HBO. And we started to talk about how to build something that would be pretty complex, had to be very robust, had to be very scalable, and at the same time be very adaptable and flexible as things like regulatory and compliance issues came into play with the IoT. And eventually, after talking to a lot of large companies and government agencies, we coalesced on the schema for Turbine. So having said all of that, here's what Turbine does. The point of Turbine is to be a master exchange for IoT data. And as you mentioned at the top of the podcast, we've decided that we can't boil the oceans on day one, so we're going to start boiling a big tub. And the tub we've chosen is transportation and logistics. And that includes transportation in all of its forms, not just futuristic self-driving cars, but trains, planes, automobiles, and ships, and everything that supports all of those. And what we've been able to produce is a system that curates IoT data by taking it from suppliers, which could be an IoT platform, could be a grouping of sensors where the data is put into a data lake or a database. And we do something that hasn't been getting done at any kind of a scale, which is we characterize the data. So the reason we do that is that in analyzing the most successful systems that run our world are things like air traffic control. How does that work? Intermodal containerized shipping. How does that work? Phone calls, especially worldwide phone calls. Those, for example, are governed by a specification called Signaling System 7, which specifies control, signaling, and metadata for phone calls. It governs almost all the phone traffic in the world. So we looked at those highly successful systems and said, what do they all have in common that makes them work, made them scale, and makes them last? And the one thing they all had in common was the idea that you don't dictate what the contents are. For example, you don't say what goes in the plane. You just say, that's a plane. But I know a lot about what that plane is and what its characteristics are. But I don't say it can only carry rubber duckies or people wearing, gold sandals. At the same time, container shipping is very similar, but the only broad distinction they have is whether or not the containers are refrigerated. And then the third one is phone calls. Nothing about the phone call specification tells you that we can only talk to each other about meeting for lunch. So we kind of resisted the temptation that a lot of people, including myself in the past, have had in the world from IT, which is, let's define it down to the nth level of, resolution. We stayed up at a high level and said, let's not touch the IoT data. Let's leave it in its native format, which there could be many. Instead, let's get all the work done in a control layer like those successful systems. That led to a very heavy-duty and long-term development of a metadata specification for the IoT. It's actually the first of its kind that can cover pretty much all use cases and types of data. And by the way, we're going to open source that pretty soon so anybody can use it. In the meantime, we started building a system that would enable that specification to be embodied in a very large-scale transaction processing system that would look at data sources, characterize it, look at its provenance, including chains of provenance, very complex structures like that. Look at things like, what do we know about the quality of the data coming from this group of sensors? And then we can grade that. Then convey all of that, plus licensing information, regulatory information, things like whether it's covered by GDPR in the European Union, and then convey all of that through the metadata. Then on top of that, we built indexes that can be searched by humans with a web interface, or more importantly, by machines using our API suite. And we also realized something we didn't even think of when we first started working on this, which is that pretty soon the thing talking to our system wouldn't be you or me or even a regular piece of software. It would actually be an AI. I just read that about 60% of the Fortune 1000 companies are now pursuing AI pilot projects, and some are going to go to production as soon as they become viable. That made us realize that it's incredibly important that we fully characterize inbound machine-generated data, in other words, the IoT data, so resolutely in terms of how we describe it that an AI wouldn't make a mistake in choosing what data to use for a given function. I also wanted to mention, very important to everybody listening here, is that, and you'll smile if you've been in IoT for a while, sort of the prevailing sort of tech industry look at things is data is just data. If you look at how the tech industry kind of pursued entertainment, they definitely just treated it as content. When they finally realized that they had to pay attention to people like songwriters and movie makers, it started to get better. And let's face it, the guy who kind of nailed that was Steve Jobs when he came up with iTunes. He and his team figured out how to talk to the entertainment industry and make them happy about the whole idea. Prior to that, it was pretty much Napster and chaos. The conformity and handling things like licensing and all that through iTunes really made it all congeal into what's now a very robust industry. Well, IoT is kind of at that same precipice where we have a lot of one-to-one relationships and bespoke things going on. It's time to really start congealing all of that into a codified schema that allows us to transact data freely, but at the same time in a way we're all happy with and trust. So the smiling part is this. If you just look at IoT data like it's another kind of data, you miss a really important thing, which is that IoT data is the data that could lead to a very bad outcome if the data is conveyed improperly or it's cleaned in the wrong way, or worse, it's improperly characterized and fed to an algorithm that doesn't know any better. So when I'm talking to people from the financial world or from the sort of Facebook, Google world, I always point out that the same IoT data that would tell an insurance company something or tell an actuarial how to price a premium or a quantitative hedge fund analyst how to get that edge in a bet they're making on the market, that same exact data could be used to tell a drone how to fly between skyscrapers, or tell a ship that it needs to turn, or tell the traffic management system in the city that you must turn all the lights red in this district right now. You do not want to get those things wrong. That put a huge amount of pressure on us in the design of every bit of turbine to get it right. And to sum up on this opening here, we've been working very hard on this, like I said, for about 2 years. We've now got the software backend ready for start taking loads. And we've then more recently built a front end to it, which is sitting on beta.turbine, terbine.io, which anybody can go look at and play around with. And turbine.io is the web front end to the big back end. It's all running in the cloud, so you can get at it quickly from anywhere on the planet. And it will eventually be the way that AIs can convey data to and from. So now that we're in beta, we're moving towards where we're going to have some really cool customer use cases to talk about.
In the next episode of our discussion with David Knight, we'll explore the technology behind Turbine solutions. And in the meantime, you can learn more about Turbine at www.terbine.com.
Thanks for tuning in to another edition of the Industrial IoT Spotlight. Don't forget to follow us on Twitter at IoT ONE HQ and to check out our database of case studies on IoT1.com. If you have unique insight or a project deployment story to share, we'd love to feature you on a future edition. Write us at eric.walenza@iot1.com.